So hi guys, in this video we're going to be going into composite functions, which is just another part of functions. So in composite functions, what you need to realize, it's basically putting a function back into itself. So let's say you had, well, not necessarily itself, it could be in any function. We are putting a function in a function essentially. So let's say you had f of x is equal to 3x plus 4. And the question was like, what is f squared x? And instinctively, you might be wondering, why don't we just square 3x plus 4? So you might think that f squared x is equal to 3x plus 4 squared. But that would be wrong. This value over here is actually equal to the square of f of x. What f squared x denotes is f of x. It's putting f of x into f of x. So in this case, since it wants us to find f squared x, and we've gotten that that's equal to this, since f of x is equal to 3x plus 4, we get that the answer they're trying to get us to solve is f of 3x plus 4, where f of x is equal to 3x plus 4. As I mentioned in the last video, the thing in the brackets is what you substitute for every value of x. So in this case, if the thing in the bracket is 3x plus 4, you substitute 3x plus 4 into the value of x over here. So we would get 3 times 3x plus 4. So for every value of x, you're substituting 3x plus 4 in this case, plus 4, which is equal to 9x plus 12 plus 4, which is equal to 9x plus 16. So f squared x is equal to 9x plus 16. And if we were to keep going on, we could even do f cubed x, which would be f of x. And this would keep going on. You could keep inputting more and more f of x, f to the power 4 of x, f to the power 5x, etc. It's just, this is composite function. Now, let's say we had f of x is equal to 3x plus 4. And g of x is equal to x squared plus 1. And let's say we were asked to find fg. First thing we have to notice is that fg is essentially saying f of g of x. So it's basically another composite function in which we're putting g of x into f of x. So if we substitute g of x into here, where g of x is equal to x squared plus 1, we get f of x squared plus 1. And that means we're putting in f of x, x squared plus 1 for every value of x that appears. So essentially, this thing over here will get put into here. So we would get 3 times x squared plus 1 plus 4, which is equal to 3x squared plus 3 plus 4, which is equal to 3x squared plus 7. So we've proven we've shown how to get f of g of x, or fg, as it might be denoted in shorthand. So this is essentially how composite functions work, putting a function in a function. If you had fgh, that would mean putting h into g, which is then all put it into f. Essentially, it's just the outermost letter is the one that's going to have the ones in between getting put into it. So the one that's all the way to the right will be put into the function next to it on the left first. So for example, f of g of h of I of j will be put into I first, then I of j will be put into h, then h of I of j will be put into g, then g of h of I of j will be put into f. It's quite tedious when you get to longer equations, but you shouldn't get more than 2 or 3 in CIM at least. Okay, so let's just take another example. Let's say we were given f of x equals 4 over x plus 2, and g of x is equal to x squared plus 3. And the question asked us, if g of f is equal to 45, then what is f of g equal to? So essentially the first thing we need to do is find what g of f is and equate it to 45. So g of f would be equal to, so that's putting f of x into g of x, so that would be g of f of x. Since f of x is 4 over x plus 2, it would be g of 4 over x plus 2, which would equal 4 over x plus 2 squared plus 3, which is equal to 16 over x plus 2 squared plus 3. And we're going to equate that to 45, since that's what we're given g of f is. So 16 over x plus 2 squared is equal to 42. So that means that x plus 2 squared is equal to 16 over 42. Then x plus 2 is equal to 4 over root 42. And x is equal to 4 over root 42 minus 2. And based on this value of x, we can use our equation for f of g. So f of g would be putting g of x into f of x, which would mean we would get 4 over x squared plus 3 plus 2, which is equal to 4 over x squared plus 5. So what we need to do is substitute our value of x, which is this, into this value of x, and to find f of g. So just essentially our final answer would be 4 over root 42 minus 2 squared plus 5. This would be our final answer. I'm not going to simplify that down because I did really just choose random numbers, and these are quite ugly, as you can see. But you get the idea. Now what I want to draw our attention to is the domain and range. So the domain and range of composite functions are quite important because let's say you had a function f of x is equal to root x and g of x is equal to x squared. And let's say we had f of g of x and f of g, and we wanted to find the domain. So f of g would mean putting g of x, which is x squared, into f of x, which would be root x squared, which is just equal to x. Now while we have our function as x, that still does mean that we have to consider the functions over here. So x, as we know, usually works for all real values. However, it wouldn't work in this case with f of x because you can't have a negative number under a square root. So in this case, our domain would also have to be in line with root x, which would make it x is greater than 0. That would be our domain for this one. So instead of having this as our function, we would only have this because that's what fits with root x. And if we take another example, let's say we have 4 over x minus 2 as f of x and 3x squared as g of x, and we have to find g of f of x. That would be g of f of x would equal 3 times 4 over x minus 2 squared, which is equal to 3 times 16 over x minus 2 squared, which is equal to 48 over x minus 2 squared. And in this instance, the domain, thankfully, would just be the same as this. However, if we were to do it the other way, where we put 3x squared into, where it's f of g of x, so let's take f of g of x, So over here, just to be clear, the domain would be x cannot be 2, as when x is 2, this thing becomes 48 over 0, which is obviously undefined, and we can't have that. However, if we take f of g, that would become 4 over 3x squared minus 2. And in this case, the only restrictions to the domain are that 3x squared minus 2 cannot equal 0, because the denominator cannot equal 0 for any function. That would become 3x squared equals 2, x squared equals 2 over 3, So x is the root of 2 over 3. So essentially in this one, the domain would be that x could not equal root 2 over 3, or negative root 3, negative 2 root 2 over 3 for that matter, or 2. Because although x is equal to 2 is valid for this function over here, it is not valid for this function over here, and hence it cannot be included in the domain. These are the restrictions on the domain for this one, therefore. So we've got these, the first two, root 2 over 3 and negative root 2 over 3, pertaining to this composite function, but the second one pertaining to the f of x function, which has restrictions. 3x squared is obviously valid for all values of x, so therefore there are no restrictions with that one. I hope it makes sense, and let me know in the comments if you have any questions. Thank you so much for watching.